Even a well-aligned AI model needs deployment-level safety controls. AI guardrails are the rules, filters, and mechanisms that constrain model behavior at runtime, preventing harmful outputs, enforcing content policies, and ensuring the AI stays within the boundaries intended for its application. Let us examine why guardrails are an essential component of every responsible AI deployment, even when the underlying model has been carefully aligned. 5 categories of guardrails form a multi-layer defense that constrains AI behavior at both the input and output stages of every interaction. Input filtering is the first line of defense in an AI safety guardrail architecture. Before a user's query reaches the language model, input filters analyze the content for signals of harmful intent, prohibited topics, or policy violations. These filters can use a combination of approaches: keyword and phrase pattern matching for known harmful content, classification models trained to detect categories such as hate speech, requests for illegal information, or attempts to elicit harmful behavior, and intent classification that analyzes the likely purpose of a query based on context. Input filtering reduces the volume of harmful queries reaching the model and provides clear audit trails of blocked content for security monitoring. Output filtering is the guardrail that operates after the language model has generated a response, but before that response reaches the user. Even when input filtering is in place, some harmful content can slip through ambiguous or indirect prompts, making output-level screening essential. Output filters analyze generated text for policy violations such as personal data leakage, harmful recommendations, regulated financial or medical advice without appropriate disclaimers, copyright infringing content, and hate speech or discrimination. In high-stakes applications, output filtering may also perform factual consistency checks, verifying that the model's response is consistent with retrieved source documents rather than containing hallucinated additions. Topic restriction is a guardrail approach that defines a scope of permissible topics for an AI application and redirects or declines queries that fall outside that scope. An AI assistant deployed for customer support on a software product has a clear intended use case. Questions about unrelated topics, politics, medical advice, financial decisions, are outside that scope and should be gracefully declined. Topic restriction guardrails use classification models to detect off-topic queries and return appropriate redirect responses that guide users back to the intended scope. This type of guardrail is particularly important for preventing an AI system deployed for one purpose from being repurposed by users for other, potentially harmful applications. Prompt injection is one of the most significant and distinctive security threats to AI systems. It occurs when malicious instructions are embedded in content that the AI processes, a document it is asked to summarize, a web page it is directed to read, or a customer message it is asked to respond to. These embedded instructions can cause the AI to ignore its system prompt, reveal confidential information, take unauthorized actions, or generate harmful content, even when the direct user interface appears legitimate. Prompt injection defense guardrails analyze not just direct user input, but all content that the model processes, looking for instruction-like content that conflicts with the system's intended operation and flagging or blocking suspected injection attempts. Rate limiting and abuse prevention guardrails protect AI systems from systematic exploitation by users who probe for weaknesses, attempt model extraction, or automate harmful queries at scale. Rate limiting restricts the number of queries a single user or IP address can submit within a time window, preventing automated abuse while minimally impacting legitimate users. Abuse detection analyses patterns of usage across multiple queries to identify suspicious behavior, such as systematic variation of a harmful query to find guardrail bypasses, or very high query volumes that suggest automated extraction. These guardrails are particularly important for public-facing AI systems where the user population includes both legitimate users and sophisticated adversarial actors. 4 essential terms that every practitioner needs to understand when designing and implementing AI safety guardrails. Input guards are the first control point in an AI system's safety architecture. They sit between the user interface and the language model, analyzing every query before it is processed. Effective input guards combine multiple detection approaches. Lexical filters catch known harmful phrases, Machine learning classifiers detect harmful intent and novel phrasing, and structural analysis identifies anomalous query patterns that may indicate adversarial probing. Input guards must balance sensitivity, catching genuine harmful queries, against specificity, avoiding false positives that block legitimate use. Overly aggressive input guards degrade the user experience for legitimate users, while insufficiently sensitive guards allow harmful queries to reach the model. Tuning this balance requires ongoing evaluation against real-world query distributions. Output moderation is the safety net that catches harmful content that escapes input filtering and is generated by the model. Because language models are probabilistic systems that can produce unexpected outputs, output moderation is a necessary complement to input guards rather than a redundant addition. Output moderation systems analyze generated text for categories including personally identifiable information that should not be disclosed, regulated advice in areas such as medicine, law, or finance, hate speech and discriminatory language, instructions for harmful activities, and content that violates the platform's community standards. Modern output moderation systems increasingly use AI classifiers rather than simple keyword filters, enabling more nuanced and context-aware policy enforcement. Policy filters are the specific classifiers and rule sets that operationalize an organization's content policies within the guardrail architecture. A policy filter for a healthcare AI system might prohibit the model from recommending specific medications or dosages without a professional disclaimer. A policy filter for a children's education platform might restrict all content to age-appropriate topics and vocabulary. A policy filter for a financial services chatbot might require all investment-related responses to include regulatory disclaimers. Policy filters must be maintained and updated as policies evolve, as new edge cases are discovered, and as adversarial actors develop new techniques for circumventing existing filters. Policy filter management is an ongoing operational responsibility rather than a one-time configuration. Jailbreaking refers to adversarial techniques designed to circumvent the safety training and deployment guardrails of an AI system, causing it to generate content it would normally refuse. Common jailbreak approaches include role-play prompts that ask the model to pretend to be an AI without safety constraints, hypothetical framings that ask for harmful information in the guise of fiction or academic discussion, many-shot prompts that progressively shift the model's behavior through a series of increasingly problematic exchanges, and prompt injection attacks that hide malicious instructions in seemingly innocuous content. Jailbreak techniques are actively shared in online communities, meaning that known jailbreaks become public knowledge and require prompt defensive responses from model operators to update their guardrail systems. Let us now look at how organizations implement and manage guardrails in production AI deployments across diverse application contexts. For practical approaches that organizations combine to build robust, multi-layered guardrail systems for production AI deployments. The major cloud AI platforms provide managed content moderation APIs that offer pre-built guardrail capabilities as a service, significantly reducing the engineering investment required to implement baseline safety controls. Azure AI Content Safety provides classification APIs for hate speech, violence, sexual content, and self-harm across text and images. AWS Guardrails for Amazon Bedrock enables organizations to configure topic restrictions, content filters, and sensitive information redaction for AI applications built on AWS. These managed services provide continuously updated classifiers trained on evolving content categories, automated policy enforcement at scale, and integration with broader cloud security and compliance frameworks, making them the most practical starting point for guardrail implementation in most enterprise AI deployments. Managed content moderation APIs provide excellent baseline coverage, but most enterprise AI deployments require custom guardrails that address the specific content policies, regulatory requirements, and business constraints of their particular context. A legal AI system needs guardrails that prevent the provision of specific legal advice that could create professional liability. A financial services AI needs guardrails that enforce suitability requirements and regulatory disclosure rules. A children's education platform needs guardrails calibrated to age-appropriate content standards. Custom rule engines allow organizations to define these domain-specific constraints using a combination of keyword patterns, regular expressions, fine-tuned classifier models, and deterministic business rules that the managed API services cannot anticipate. No single guardrail mechanism is sufficient against a sophisticated adversary or all edge cases of a complex AI application. Defense in depth applies the same principle to AI safety that it does to cybersecurity. Multiple independent layers of control, each covering different failure modes, such that failure of any single layer does not result in a safety violation. A robust multi-layer guardrail architecture combines model-level safety through RLHF and constitutional AI training, application-level input and output guardrails, infrastructure-level access controls and rate limiting, and human-in-the-loop review for high-risk outputs. Each layer reduces risk, and the combination provides the reliability required for enterprise deployment. Guardrail systems are not static configurations that can be deployed and forgotten. The adversarial landscape evolves continuously as new jailbreak techniques are discovered and shared, as the model's behavior drifts, and as the application's user population and use patterns change. Effective guardrail operations require continuous monitoring of guardrail activation rates, tracking which filters are triggering, at what frequency, and in response to what types of queries, and alerting when patterns suggest systematic probing or novel attack techniques. Monitoring dashboards should surface trends in blocked content categories, identify emerging query patterns that may indicate new attack vectors, and trigger automated or human review when guardrail violation rates exceed established thresholds. Let us bring together the essential points from our exploration of AI safety guardrails. To explore more key concepts in generative AI, check the link in the description. If you found this helpful, please like and subscribe. Thank you for watching. If you found this helpful, please like and subscribe. See you in the next video.